Okay, today we're going to start with section 1.4. And this is Introduction to Variable Expressions and Equations. Okay. And we're going to start with just a quick review on exponents. So let's look at this. 5 times 5 times 5 times 5. So you have 5 multiplied together 4 times. This can also be written as 5 to the 4th power. 5 to the 4th power. Now the 5 here is called the base. The 4 is the exponent. All right, so we'll look at this example, 3 to the 3rd power. Okay, if you're asked to evaluate 3 to the 3rd power, you know that means that you're multiplying 3 times 3 times 3. So that would equal 3 times 3 is 9, and 9 times 3 is 27. So that would equal 27. If you have 2/3 to the 4th power, that means that you're multiplying 2/3 times 2/3 times 2/3 times 2/3. Multiplying 2/3 times itself 4 times. So on this one, you would just multiply the numerators together and multiply the denominators together. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So you'd have 16 on the top. And then in the denominator, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So you get 81, so it'd be 16 over 81. All right, any questions on exponents? All right, next is the order of operations. The order of operations. Now there's a saying to help you remember the order of operations, and it's please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. That's to help you to remember what order to go in. So the P in please, that stands for parentheses. Or any other grouping symbol. It could also be brackets or absolute value, but P for parentheses or any other grouping symbol. So do that first. Then the E, that stands for exponents. So that means you would go through and do all of your exponents next. Okay. The M and D is done in the same step. You do it in order from left to right, and it stands for multiplication, and division. And you do those in order from left to right. So that means if the division comes first, you do the division first. But if the multiplication comes first, you do that first. And then the A and D are done in the the A and S are done in the same step. And that stands for addition and subtraction. And that's going to be done in order from left to right. So that's your order of operations. Okay, so let's do some examples. Let's do 5 plus 6 times 2. 5 plus 6 times 2. You're going to do your multiplication first, right? You have addition and multiplication there. You know your multiplication comes first. So that's 5 plus 12. And then 5 plus 12 is 17. So that equals 17. Now let's look at this one next. Let's do 2, and then in brackets, 5 plus 2, and then in parentheses, 8 minus 3, and then close your bracket. So in this one, we have some grouping symbols. We have parentheses, and we have brackets. Now, if you have two sets like that, you need to do the innermost set first. So we need to do the parentheses first. And I'll just bring everything else down. So that's 2, bracket, 5 plus 2. And 8 minus 3 is 5, right? Like that. So do that first. Okay. Alright, now we're going to do what's in the brackets next. So you have addition and you have multiplication in the brackets, right? Remember that 2 with that 5 in parentheses next to it? That means you're multiplying 2 times 5. So you have addition, you have multiplication. You do your multiplication first. So that's 2 times 5 plus 10. You can continue simplifying what's inside that bracket. So it's going to be 2 times 15. And now if you have a number next to the 15 in brackets, you would just multiply there. So 2 times 15 is 30. Okay, any questions? Okay, the next example, the absolute value of 6 minus 2 plus 3 all over 8 plus 2 times 5. Now, if you have a fraction like this, you're just going to do the top and bottom separately, and then at the end we'll simplify if we can. So just work the top like it's one problem, the bottom like it's another problem, and then simplify in the end. Now, in that numerator, we're going to do what's in absolute value symbols first, because those are grouping symbols, just like parentheses. So do that first. Okay. So that's the absolute value of 4 plus 3 over, and since we're working the bottom separately, we can go ahead and start working that. All right, you know you would do your multiplication first, so that's 8 plus 10. Okay, now in the numerator, you need to work out that absolute value. The absolute value of 4 is still just 4. So it's 4 plus 3 over 18. And then add what we have in the numerator. 4 plus 3 is 7. So we get 7 over 18. That cannot be simplified, so that's your answer, 7 over 18. Okay. Let's move on to evaluating expressions. Evaluating expressions. We're going to look at this one first. If x equals 1, y equals 3, and z equals 5. Evaluate the absolute value of 2x plus 3y. Okay. All right, let's work it out. Let's see, if you put 1 in place of x and 3 in place of y, you would have the absolute value of 2 times 1 plus 3 times 3. You substitute in. Okay, now we're going to work out what's inside the absolute value first. All right, 2 times 1, do the multiplication first. 2 times 1 is 2, plus 3 times 3 is 9. And then go ahead and add 2 and 9 together. So we have the absolute value of 11. And then just take the absolute value of 11. You know that you just keep it positive. Absolute value is always positive. So the answer there is just 11. All right, let's look at another one. If x equals 12, y equals 8, and z equals 4, evaluate x squared plus z over y squared plus 2z. That's x squared, or x to the second power, plus z, all over y squared, or y to the second power, plus 2z. So we're going to substitute in our values for x, y, and z. So we'll have 12 squared plus 4 all over 8 squared plus 2 times 4. Okay, remember we'll work the top and bottom separately. So if we do do the top first, you'll do your exponent first. So 12 squared, that's 144 plus 4 over. And then in the denominator, you have an exponent, you have addition, and you have multiplication. So you'll do your exponent first. 8 squared is 64. Okay, go ahead and add the top. 144 plus 4 is 148. And then on the bottom, you would do your multiplication next. 2 times 4 is 8. So we'd have 64 plus 8. So if you add the numbers on the bottom, you have 148 over 72. So then let's try to simplify that. Let's see, a number that'll go into 148 and 72. Okay, we'll start with 2. 72 divided by 2 is 36. And 148 divided by 2 would be 74. Okay, and you can still keep reducing it, can't you? 2, since both of those are even numbers, we know 2 will go into it again. So let's just divide 2 into it again. 2 will go into 36 18 times. And 2 will go into 74, is it 37 times? Is that right? Yeah. Now, will anything else go into 37 and 18? Nothing besides 1, right? So that's simplified. So that's your answer right there. Okay. All right, now we're going to try to determine if a number is a solution to an equation. Determine if a number is a solution to an equation. Okay, is 6 a solution of 3x minus 10 equals 8? Is 6 a solution of 3x minus 10 equals 8? Okay. All right, let's work it out. Make sure. So you're going to substitute 6 in place of x. So you're going to have 3 times 6 minus 10 equals 8. Substitute your 6 in. And then you're just going to work each side of the equation out. Make sure you get the same thing on each side. So really we only have to work out the left-hand side of this one. 3 times 6 is 18. So you have 18 minus 10 equals 8. Then 18 minus 10 is 8. So see, we get 8 equals 8. You get the same thing on each side. So the answer there is yes. That is true. Okay, the last thing we're going to go over today is translating phrases to expressions and statements to equations. Translating phrases to expressions and statements to equations. So in other words, it's going to be given to you in words, and we're going to translate it into a mathematical, either expression or equation. So let's look at this one. 3 times a number increased by 72. Three times a number increased by 72. Okay, we don't know what the number is, so that's going to be our x, or you could let it be any variable, but we're going to use x. So 3 times x, you could just write that as 3x, that means 3 times x. Increase by means you're adding, right? So we're going to increase it by 72, so it's 3x plus 72. Like the next one, 1 increased by 2 equals the quotient of 9 and 3. Okay. 1 increased by 2 equals the quotient of 9 and 3. So this one, we don't have any unknowns. We don't have any x's. We know what all of our numbers are. So if we just write this out, 1 increased by means you're adding. So increased by plus 2 equals, it's just an equal sign. Now quotient, what does that mean you're doing? Dividing, right? So the quotient of 9 and 3. So you could write that as 9 over 3, or you could write that with 9 and a division sign and 3. Either way you want to write it's fine. So 1 plus 2 is equal to 9 divided by 3. Okay, we've got one more example. 3 is not equal to 4 divided by 2. Three is not equal to 4 divided by 2. So it's 3 is not equal to, that's your is not equal to sign. And 4 divided by 2, you could just write 4 over 2. So that's 3 is not equal to 4 divided by 2. Okay, any questions on this? Hold on a second. I can't find it.